All right, so today we are talking about the pH of the solution. We're going to cover both acids and bases, and let's get into some background information that we already know. We already know the pH scale. We know that it runs from 0 to 14, although you can go beyond both of those limits on both sides. 7 is neutral in the middle, acidic is less than 7, basic is greater than 7. We also know that acids are compounds that produce hydronium ion, H3O+, bases dissociate to produce hydroxide ion. We know about strong acids and strong bases, that they dissociate fully or 100%, and then if I know the concentration, the stated concentration of the acid, hydrochloric acid for example, that automatically gives me the concentration of hydronium ion, which of course does not work when I'm talking about a weak acid, and likewise for bases, strong bases dissociate 100%, weak bases don't. Okay, so all of those things are going to be kind of important. We won't necessarily need them all to the same degree, but all of those things are going to be kind of important. So how do we get pH numbers out of that? Now, yeah, sure, you can take a pH meter or a pH paper and you can dip it and it'll tell you the value, but what does that value actually mean other than it means it's acidic or it means it's basic, or how acidic or how basic? Okay, if we have an acidic solution, we're going to have this formula, this mathematical formula, this equation, where pH, we'll talk about that in a moment, is the negative log of square brackets H3O+. Now, we're going to break that down a little bit because there's actually a lot of notation in there that we probably haven't seen yet. So pH is the negative logarithm of the hydronium ion concentration. Those square brackets, we haven't used them at all or much at this point already, but they mean concentration. Nice square brackets around there. Okay, logarithm, what in the world is that? If you go to your calculator, there's a button on there that says log. It may be all lowercase, it may be all uppercase, and right above it is usually this 10 to the exponent x thing. I don't want to spend too much time talking about the math behind that. There's probably great resources for that. Perhaps we'll talk about it another time. But at the bottom line is that logarithm button, what it's going to do is it is going to tell you the exponent on 10 that gives you the question or the number that you input. In other words, if I type in log of 1, I get a 0 because 10 to the exponent 0 is 1. If I put log decimal 01, I get -2 because 10 to the exponent -2 is decimal 01. And I can do that for any number. It doesn't have to be, one of those nice ones like 10, 100, 1000, 1 million, or decimal 0.00001. I can do it for any number because some exponent on 10 would give me that number. Now, we usually use fairly small concentrations for acids and bases, so that's why I've got that negative log in there so that my pH values come out as positives. And again, like I said, I can do that for virtually any number, both large ones and small ones. Okay, pH. If I use that formula to calculate the pH, where that's how I got those pH numbers in the first place, then if I have a solution that is decimal 0.1 moles per liter of hydronium ion, then the pH is going to be the negative log of that number, and it gives me a pH value of 2. That's really all it is. pH numbers come from these concentrations of hydronium ion if I'm using that formula. Okay, I'm going to give you a second to, you should pause this, you should write these down, you should calculate these out. I'll show you the answers in a moment. But notice all of these values are small concentrations or small-ish concentrations of acids. And I want you to kind of look at the pH values that you get. And here are the pH values you get. If you have not calculated those out, you really should, but we're going to move on for now. Okay, if I know the pH value, how do I get the concentration? Well, remember that 10 to the exponent part on the calculator right above the button, second function to get there? Okay, that's what I'm going to do. So hydronium ion concentration is 10 to the exponent negative pH, whatever that is. Now again, it's negative pH, so if my pH is a 3, I have to put it in as 10 to the exponent negative 3. So if I have a pH of 1.5, fairly acidic pH, and I put that in, got them all coming out there. There we go. That's not what I wanted to do. Oh well. Then I get a concentration of hydronium, first one of decimal 0.316. Now, I kind of want to point out that a pH of 1.5 feels really acidic, but a concentration of decimal 0.316 doesn't feel all that acidic. So, and it's basically because it's 10 to the exponent, but also even low concentration can be pretty acidic. Okay. Bases. So far what we've done is we've talked about acids, and it's a fairly simple calculation, although you do need to pay attention to the buttons that you're pushing and what they mean, even though for us it's because we don't really understand the math, maybe it's going to feel like a magic button, but we got it. That's where we're going to fall short on it, right? Okay, bases. Well, bases, we know the concentration of hydroxide ion, not the concentration of hydronium ion, and everything about pH is hydronium ion, at least initially. So the first thing I'm going to have to is work with, I'll do the talking like I was going to, I guess. If I know a basic pH, if I want to know a basic pH, how do I do that? Oh, there we go, the pOH scale. pOH scale looks a lot like the pH scale, except it's backwards. It also runs from 0 to 14. 7 is neutral in the middle. Yes, you can go below 0. Yes, you can go above 14. But notice what's more important is that if I take the pH value and the pOH value, they always add up to be 14. Now, you say always 14? For our purposes, yes, always 14. When are they not 14? Special cases. Not going to worry about it though. Okay, the formula for the pOH is actually very, very similar to the formula for pH, and it's on purpose for that. However, that's where we start to fall and make mistakes, is not knowing when we're pushing the button what it's telling us. Okay, negative log of the hydroxide ion concentration. Now I'm going to give you this. You'll see this various places. This basically gives me a roadmap of how do I get from, say, the concentration of hydroxide ion to the pH, or the concentration of hydronium ion to the pH, or from the pH to the concentration of hydroxide. Now you might be wondering, hey, do I ever need to go from the hydronium ion concentration to pOH? No, I mean you could, but there's no reason to do that. Hey, is there a way to close off that fourth side? Yes, we're not going to worry about it right now though. So we'll give you something to look forward to. So if I want to find the pH of a base, notice I had to go back and I had to go around two corners. Okay, so I'm going to first find the pOH using the formula I had before, and then I'm going to use that relationship where the one plus the other adds up to 14. All right, so for example, if I'm trying to find the pH of a solution that's 0.035 moles per liter of hydroxide ion, again, I need to be able to recognize that that thing is a base. First I find the pOH, which is the negative log of the concentration of hydroxide ion. And that gives me a pOH value of 1.46. And then I'm going to do 14 subtract the pOH, and that's going to give me the pH. 2 steps instead of the one that we had before, but still not that hard. If I know the pH and I need to know the concentration of the base, then I'm going to first calculate the pOH again, have to go through the pOH, and then I'm going to use that to find the concentration of hydroxide ion. In other words, if I have a solution that has a pH of 11.6, I first find the pOH, because pH tells me hydronium ion, pOH tells me hydroxide ion. So find the pOH, use that as my exponent, negative exponent, to get the concentration of hydroxide ion. And that is really all there is to it. The big problem is going to be keeping track of what the button is, or when I'm pushing the button. Am I doing the 10 to the exponent? Am I just doing the logarithm? Is that telling me a pH or a pOH? And that is going to be your big job. Talk to you in the time.